In this video, we're going to look at sequences and how to generate the terms. Before we start, we're going to look at a couple of definitions. So first of all, a sequence is a function whose domain is the set of consecutive integers. Essentially, you can think of a sequence as just a list of numbers that have a mathematical pattern to them. So it's a function, but each domain value has to be an integer. So we can't have x values with fractions, decimals, 1.5, anything like that. So an example here is the sequence R, which is 2, 6, 12, 20, 30, etc. The position is the integer value from the domain. The position just tells you where you are in the sequence. Am I at the first term, the third term, the fifth term, the 100th term? And it's usually denoted with an n, but really you can use any letter. We typically use n because it represents n for integer value, whereas when we use x, we assume that that is all real numbers. The term then is the particular numbers in the sequence. So in our example, 2, 6, 12 are terms, and then their associated positions 1, 2, and 3 would be my domain values. Usually when we're talking about a sequence, we use some subscript notation for it. So you can see kind of writing our example down here at the bottom. My first term we would represent as r sub 1 is 2. Our second term, which is r sub 2, is 6. Our third term, r sub 3, is 12. Our fourth term, r sub 4, is 20. The fifth term, r sub 5, is 30. All of those were given to us. So again, we're going to look for that pattern. So if we can see this is plus 4, and then this is plus 6, and this is plus 8. This is plus 10. So it looks like we're adding consecutive even numbers. So then this would be plus 12. So 30 plus 12 gives us 42. So r sub 6, my sixth term, is 42. And then when we talk about the nth term, really we're talking about a formula for this. So we represent that with r sub n. So that means any term. So we're going to come up with formulas for that, and we'll sort of talk about how to do that. There's two different ways that we can write formulas for sequences, and the first is an explicit formula, and this is what you're probably more familiar with. So an explicit formula gives us a formula which shows the nth term of the sequence in terms of n. So basically this is telling us that we can find any term if we simply know its position. So in an example here, I have r sub n equals n times n plus 3. So if I want the first term, r sub 1, we just plug 1 in for n. So 1 plus 1 plus 3, which is going to give us 4. If I want the fourth term, r sub 4, we're just going to go 4 times 4 plus 3. So 4 times 7 is 28. If I want the 100th term, r sub 100 is 100 times 103, which is going to give us 10,300. So I can generate those terms very easily just by putting in the position number. The other type of formula that we can have for a sequence is called a recursive formula. And this is a formula which is going to tell me my first term or terms, and then it tells me how to find any other term or the nth term of the sequence by using the previous terms. So this recursive formula means that in order to find any term, I have to know the term before it, which means if I want to find the 8th term, I need to know the 7th term. And to know the 7th term, I need to know the 6th. And to know the 6th, I need to know the 5th, all the way back until the first term. So essentially, when I'm using a recursive formula, I have to start at the first term and build my way up to whatever term I'm trying to find. So again, in the example that we have here, we have r sub 1 is 1, so my first term is 1, and then r sub n, so this, remember, means any term. To find any term, we're going to use r sub n minus 1. So notice the subscript is 1 less than the subscript on the left side of the equal sign. So this means the previous term, and then plus n, so then we're going to add the position. And then there's some words here. This one says for all n greater than 1. Sometimes it might say for all n greater than or equal to 2. So this is just telling us that we use this second equation here for my positions that are past the first position. So this is sort of like our legal words there. So in this case, let's say I wanted to find the 6th term, but remember with a recursive formula, that means I have to build my way up to the 6th term. So I know my first term is 1, and then my second term, so now I'm going to use this equation here, r sub n equals r sub n minus 1, so 2 minus 1 plus n, which in this case is 2. So this is going to give me r sub 1 plus 2, and then I'm going to plug this in. So I'm going to get 1 plus 2, which is 3. So I got my second term, so now I can continue on. I'm going to find my third term. So to find my third term, now n is 3, so now we're going to go r sub 3 minus 1. Oops. Plus n, which remember in this case is 3 because I'm finding the third term. So this is going to simplify r sub 2 plus 3, and then again we're going to plug in. So this is going to give me 3 plus 3, so my third term is 6. So then r sub 4 is going to give me r sub 4 minus 1 plus 4. So r sub 3 plus 4, so plug in the 6. So 6 plus 4 is going to give me 10. So then I've got 2 more terms to build to get to that 6th term. So I want to find my 5th term, so r sub 5 minus 1 plus 5 here. So r sub 4 plus 5. So I'm going to plug in that 4th term, which was 10. So 10 plus 5 gives me 15. And then finally, r sub 6 is going to be r sub 6 minus 1 plus 6. So r subscript 5 plus 6. So 15 plus 6, which will give us 21. So recursive formulas are a little more difficult to work with, but sometimes a sequence can only be written with a recursive formula. The explicit formula might not be as easy to get to. All right, so just doing a little practice here. We're going to find the first 5 terms in the 10th term of the sequence defined by b sub n equals 7 plus 4n. So first thing you want to note is that this is an explicit formula. And I know this is an explicit formula because the expression after the equal sign only contains an n, so all I need to know is my position. So we want to find the first 5 terms in the 10th term. So we're going to find b sub 1. So remember, we just plug 1 in for n. So 7 plus 4 times 1 is going to give us 11. And then b sub 2, 7 plus 4 times 2 is going to give us 15. And then b sub 3 is going to give us 19. B sub 4 give us 23. B sub 5 is going to give us 27. And then remember, since this is an explicit formula, I want to find the 10th term. I can just find that directly. I don't have to build all the way up. So I can just go b sub 10 is going to be 7 plus 4 times 10, which will give me 47. Okay, so if I want to generate explicit terms on my calculator, the first thing that I'm going to do is check my table settings. So I'm going to go second window to go to my table settings. It doesn't matter what table start and delta table are on. What matters is that independent is on ask and dependent is on auto. So we want to make sure independent is on ask, dependent is on auto. Then we're going to go to our y equals, and we're going to put in this expression. So we're going to type in 7 plus 4x. The equation has an n in it, but it's just representing your independent variable, so it's perfectly fine. You can use the x. So now what I want to do, instead of looking at the graph, we're going to go to the table. So second graph to go to your table. You may have numbers in your x column, and if so, you should be able to press your delete button to remove them. If you can't remove them with your delete button, then you didn't set your table settings properly, and you want to back up and check your table settings. So what we can do here is we can enter in any position that we want, and we can find the term for that. So I want the first term. So my first term is 11. I want the second term. And then remember, we wanted the 10th term, so I can just put in 10. And then I've got my terms there. All right, second example, we're going to do the same thing here. We're going to find the first 5 terms in the 10th term of a sequence. So here, remember, this is a recursive sequence. And we know this from two things. First of all, there's more than one equation. So always with a recursive sequence formula, you're going to have at least two equations. And then the other thing is that in that second equation, you have the subscript notation. So we have b sub n minus 1. So that's another clue that tells you you're doing a recursive formula. So here we're going to generate these recursive terms. So b sub 1 equals 3. So that was given to us. So that was given to us right here. So we know that. Then this second formula, so b sub 2, so when n equals 2, we're going to say b sub 2 minus 1 plus 5, which is going to be b sub 1 plus 5. So now I'm going to plug in, so 3 plus 5 is 8. So then we're going to do that same thing, so b sub 3 is b sub 3 minus 1 plus 5. So second term plus 5. So we're going to plug in, so that's going to be 8 plus 5, which is going to give us 13. So b sub 4 is going to be b sub 4 minus 1 plus 5. So third term plus 5. So 13 plus 5, which gives us 18. Fifth term is going to be b sub 5 minus 1 plus 5. So b sub 4, so fourth term plus 5. So 18 plus 5 is going to give me 23. So we've got our first 5 terms. Now remember, we need the 10th term. So in order to find that 10th term, we have to keep going through this process. But we can kind of do this a little bit simpler instead of writing all this out. So essentially, every time we're just taking the term before it and we're adding 5 to it. So to find the 6th term, we're going to take that 5th term, which was 23 plus 5, which will give us 28. And then the 7th term is going to give us 28 plus 5, which will give us 33. 8th term, I'm going to take the 7th term plus 5, so 33 plus 5, which is going to give us 38. 9th term, 8th term plus 5, which will give us 43. And then finally the 10th term, 43 plus 5, which will give us 48. All right, so if you're going to do recursively to generate these, we're going to go to our calculator and we're just going to use the home screen. So the first thing we're going to do is we're going to enter our first term in, so 3, and then just press enter. And then in our equation where we have this subscripted variable, so where we have the b sub 2 minus 1 or 3 minus 1, 4 minus 1, etc. Really that's the answer from before, right? So we're going to use answer on our calculator. So we're going to do second negative sign to get answer. And then our formula said we're going to take that answer and we're going to add 5 to it. So we're going to go plus 5 and then press enter. And then I've got my second term, which is 8. You don't even have to type that again each time since it's just answer plus 5. You can just press enter. So there's my third term, fourth term, fifth term, and then we can keep going 6, 7, 8, 9, and 10. So you can generate those recursive terms by using your answer button.